We still have two speakers separated by a distance of 2.5 meters that are 10 meters away from a wall. Now we want to figure out what is the distance between the central maximum and the first place when the listener detects no sound. It's always a good idea to depict what's going on with these type of problems, so I'm pulling in an image from earlier in the presentation. Here we see two speakers lined up next to each other, 2.5 meters apart, and the sound waves are traveling and hitting the wall. The place where there's a loud spot is called a maximum, and the central maximum is labeled m equals 0. And then we see there are places where the waves interfere destructively, resulting in no sound. And we want to figure out what's the distance between m equals 0 and the first place where there's no sound. So we'll use the same formula we derived earlier to find this distance with one slight change. We have x equals m, and now we need to add 1/2 to m because the waves destructively interfere at this spot, which means they're 1/2 wavelength out of sync. M plus 1/2 times the wavelength times the distance away from the wall divided by the distance the two speakers are separated from each other. And we just have to make sure we pick out the correct givens for each of these variables. So we know since it's the distance from the central maximum that m equals 0. We calculated wavelength in the previous problem, which is 0.136 meters. L is equal to the distance away from the wall, or 10 meters. And D is equal to the distance between the two speakers, or 2.5 meters. Plugging in our values here, we have x equals 0 plus 1/2 times 0.136 meters times 10 meters divided by 2.5 meters. And we'll see that one of these meters cancels out. So our answer should be x equals 0.272 meters.